Hello everyone, welcome to the Smart Interview YouTube channel. This is Jay and Siddham. And today we are going to solve problems from LeetCode's Biweekly Contest number 136. So without wasting any time, let's get started. Okay, let's start with our third question. So this question is extension of the second question that we just discussed. So same thing, we are given a grid of size m by n, and we can flip values in the grid, that is from make 0 to 1 and make 1 to 0. And in this question, we have to return the minimum number of cells to be flipped so that we can make all rows and columns palindromic. In previous question, we are asked to make either rows or columns, but in this question, we have to make both rows and columns palindromic. And the total number of ones in the grid should be divisible by 4. So we have to take care of 2 points that is asking here. The rows and columns should be palindromic, as well as the count of ones should be always multiples of 4. Okay, so we have to keep these two things in mind and find out the minimum number of cells required to make the or minimum number of cells that are needed to be flipped so we can make the matrix palindromic. Okay, so yeah, let's look at the example. So as you can see here, uh, we want to make rows and columns as palindromic, right? So if I want to make the first row palindromic, simply I can make this as 1, right? Similarly, since this is a 1, this is a 1, I have to make this as 1 as well. So if I make this particular one as using this particular one, if I make its respective row and column elements as 1, I needed 2 flips and everything is palindromic. And coming to the center row and column, the middle row and column, they are respectively palindromic, and one doesn't make a difference because this is the central element. But the question also asks us that we have to make sure that the number of ones is equals to multiples of 4. But with this one we have total of 5 ones, so we have to remove it. So it uses two zeros which are flipped to ones plus one center one which are flipped to 0, that is total count of 3, that is the output. But here one thing is for sure, that we have to keep it as 0. Yeah, we have to keep it as 0. Any central element should be 0, or else it will create non-multiple of 4 value, that is for sure. Now, one more way to do this is we can make this ones as zeros, right? We can make this ones as zeros. So all will be zeros. So palindromic in all directions, right? And center 1 to 0. This is also giving us two flips of ones and plus 1 1 which is flipped to 0. So anyway you do, you are getting 3 as the output. So 3 is the output for this question. Okay, so let's use this. Let's do the same thing. Let's use the logic and use a bigger example so I and try to understand the solution better. Okay, so yeah, let's take a 5 by 5 matrix. Okay, let's take a 5 by 5 matrix. So let's start with the first element. Let's say we are using for loops and iterating, and let's say this is our ith row and jth column element. All right, ith row, jth column element. So for this element, we should make sure that the row and column should be palindromic, right? So the row and column should be palindromic for this. Okay. So if we want to make the row palindrome, what we have to do is we have to make sure we flip the respective row element, and which is that is what we already discussed. It is nothing but in the ith row we are going to change m minus j minus 1th element, right? M minus j minus 1 element. This is same as our previous question that we already discussed, right? So m minus j minus 1, this is 0 comma 0. So we are checking for, let me write this columns here, 0 comma m is 5, 5 minus 0 minus 1. So simply we are checking for 0 comma 4. They should be equal. They both should be equal. That is one thing, right? Next, respect to column element should also be equal. So this row element we checked, the column element. So that is the jth column is as it is, but the we have to change the row which it appears, right? Same column. So that is simply n minus I minus 1. So j remains the same, that is 0th column remains the same, and 5 minus 0 minus 1, which is nothing but 4. So fourth row, 0th element should be the same as current element. Okay, and can you see something here? If I want to make you know using ing, if I want to make row and column as palindromes, I will either change these values, right? I might change these values. Because of changing these values, they are affecting one more value, right? If you see, for this element, row is set but column is not set. Column is which value? This thing, right? And similarly, for the element in the column element is set but the row element is not set, and the row element we are talking about is here. So for the row and column elements we change for the value of ing, it is affecting one more value, the diagonal value which we have, and we can simply figure it out, right? That is just the row and column. Let's call it as the respective diagonal element. So it is going to be in the n minus I minus 1th row and m minus j minus 1th column. That is n minus I minus 1 is 4 comma 4. So if we want row and column to be palindrome and we select a value, we should make sure that these three values which are linked to it are all representing the same value, right? All representing the same value. Okay, so let's say that means if it is, all these values should be either zeros or all these values should be ones. Okay, if all these values are ones, that means we are also validating the second point. If all these values are ones, that means simply they are going to be multiples of 4 ones. Or if all these values are 0, still it is going to be a multiple of 4, right? So simply what we can do is we can just count how many ones are there in these values. So 1, 2, 3, 3 ones. Okay, so if I want to make all of them as ones, it is 4 minus 3 moves. So all ones is 4 minus 3. So I need to make one flip to make all of these as ones. Okay, all ones. And if I want to make all zeros, I have to flip all three of them. And which one we would pick? And the question is quite simple. We want minimum of these two, right? Minimum of these two. So that is the first logic. So we can apply this for the next set of elements. So let's take this value in the same row. Let's yeah, these things are done already. Now let's take this value, 0th row, first column. So what are we going to check with? The same as respective element in the same row, respective element in the same column, and the element which is being affected with these two new changes. Okay, so these four for the particular for 0 through first column element. Next, now we are only going till half of it, so this particular row is not touched yet, right? We will not touch this particular row. Okay, so similarly we'll go with 1 1, so these are touched, right? Next, if we go with this 0, these are touched, right? So if you see, what are we left with? What are we left with is, we are left with the middle row and middle column. We are left with the middle row and middle column. And if we make these as palindromes, our question will be almost done. Not exactly done, because we have to take the second point, that is number of ones will be multiples of 4s. Right. Number of ones should be multiple of 4s. Okay. Next, so let's see. So 1 and 1 are already a pair, right? 1 and 1 are already palindromic, right? So what we'll do is, we'll take this and try to make them palindromic, and at the same time we'll try to, uh, make multiples of ones as multiples of 4s. Okay, so let's take the column part first. So what can be the issues here? So let's say, uh, let's make this as a 0. Let's make this as a 0. Okay, so if these are both zeros, the values both are zeros, I don't think we have to worry about them, because if both are zeros, they are already helping in forming a palindrome, and we don't have any constraints on multiples of something like multiple fours on zeros. So if zeros, we don't have to do much about it, right? Okay, we don't have to do much about it. I think this was one here. Okay, uh, yeah. Next, what else? What if we have two ones? Yes, that is 0 says 0 comma 0. What if we have two ones? So if we have 1 comma 1, okay, they are forming palindromes. But the issue is, the number of multiples of 1 should be, the count of 1 should be multiple of 4, right? So if we have pairs like 1 comma 1, we want them to be in even count, right? Even count, because two pairs of 1 comma 1 make sure that they multiply their sum up to be a multiple of 4, right? So what we can do is, we can count double ones, and we want double ones always to be even. Okay, double ones count should always be even, so that they will balance out each other. And if they are already double ones, they are managing the first point, that is palindrome. And if they are even, then we can say that they're also, managing the point of multiples of 4, right? Multiples of 4, which is the second point we were discussing about. Even ones, okay, yeah. Next, what if we have odd ones? Okay, let me write these cases together. Yeah, let's write these cases together. If zeros, we don't have to do much about it, right? If zeros, we don't have to do much about it. If the double ones are already zeros, if double ones are already even, so we also don't have to do much about it. And if double ones or double ones count is odd, that means there is a extra pair of 1 comma 1. Okay, there is an extra pair of 1 comma 1. So let's look at this case where we have double ones extra, right? When we have extra double ones, okay, when we have extra double ones, what can we do is simply make them both as 0 comma 0, which would take 2 flips. But we can do something better. So till now we talked about 0 comma 0 pair and 1 comma 1 pair, but if you remember, we can have 1 comma 0 or 0 comma 1 pair, which are kind of the same thing, right? Which are kind of the same thing. So if we want to convert 1 comma 1 to 0 comma 0, it requires 2 flips, but we already have a 1 comma 1. So we can come if we have a extra pair of 1 comma 0, we can make that to 1 comma 1 to simply get get even number of double ones count. Okay, so if we rewrite it, we can simply write this as something like this. If the double count value is odd, and if 1 comma 0 pairs count is greater than 0, we can simply add one step to our answer plus equals to 1, right? Answer plus equals to 1, else answer plus equals to 2. That is, we are making 1 comma 1 to 0 comma 0. So in this case, our answer plus equals to 2, but in this case, we only increment our answer by one part. Okay. Now in this case also, if it is even number of ones, it is done. It is even number of double ones, it is done. It is odd number of double ones. We have these two cases. And what about case of ones? Okay, case of that is 1 comma 0, 1 comma 0. What in that case? We can simply make them zeros, right? We can convert these to 0 comma 0. If we convert these to 0 comma 0, they are going to be palindromes and we don't have to worry about multiple of 4 ones thing. Okay, so these are the steps we have to follow to get things done. So let's just go through the solution once again. So simple thing is that for every I comma j, we can just count number of ones, and we can decide if I have to make all ones or all zeros for the respective 4 indices for every I and j. We are getting 4 indices including that, right? So we can count number of, should we make it to all to ones or all to zeros and just add it to our answer. The issue comes when we are talking about the central row or central column. Okay, and in central row or central column, we already discussed one point that if the center is 1, we'll make it to 0. That is one thing that we have to not miss. Okay, after that yeah, making the center row and center column as palindrome, we can simply achieve it by using the previous solution that we already discussed. But the issue with that solution is issue with this particular question is we also have to figure out multiples of 4. So what are the possible pairs we have when we are talking about making them palindrome? 0 comma 0, 1 comma 1, 1 0 or 0 1. That's it, right? So 0 zeros, they're already palindrome, multiples of 4, nothing to be changed here. When it comes about 1 comma 1, we need to know number of pairs of 1 comma 1. 1 comma 1 are already palindrome, but we need multiples of 4. right? So that is where the issue comes. So first we will count the number of 1 comma ones. Okay, if the 1 comma ones pairs that we have are already even, they match out with each other, and we only have to figure out how many 1 comma zeros we have to convert to these things. Fine. Next, not that is not the case. Then the other cases, double ones that we are counting are odd. So two possible cases. One thing is we can convert these 1 comma ones to 0 comma zeros in the worst case. But a better case would be take one of these 1 comma zeros that we have and convert them into 1 comma 1 and add just one flip to our answer, or else the other way, if you don't have extra 1 comma zeros anywhere, we can just add 2. So this is the logic, and if we implement all of them, our code should be working fine. So I hope everyone understood this. We'll move on to the coding part. So let's continue with the code for this question. So first, let's take the dimensions of the matrix. It is given that the matrix is of size m by n, but I'm just taking it as n by m. So m is length of grid of 0. Okay. Now let's say what we'll do is we'll do this in parts. First, let's assume that there are no particular central rows or columns. So we will just go with answer equals to 0, and we'll cover the four cases, four indices we are talking about. Okay. So for I in range of n and for in range of m. So what we'll do is we'll count number of ones and we'll figure out if we can take all ones or zeros. So I j plus the element in the same grid, same row. So ith row and m minus j minus 1 column plus same column but in different row. So grid of so it will be grid of n minus I minus 1, and the column remains the same, so the same, and the last diagonal element we are talking about. So n minus I minus 1 row, yep, n minus I minus 1 row and m minus j minus 1 column, and so we'll add minimum value to our answer, that is converting them to zeros or 1. Converting all of them to zeros is simply the count, or converting all of them to ones is 4 minus the count. So yeah, that is straightforward answer. Now we have to check if rows or columns are there. So what we'll do is odd number of rows or odd number of columns are there. So we'll say double number of ones, double ones that we discussed. So 2 1 pair and single ones. Okay, both are 0. Now let's just check if number of rows are odd, that is we are going to have a center row which we did not touch yet. So here again we'll calculate the count of ones for each row. So yeah, for each element in the row. So the row is fixed for I in range half of the columns. So m by 2 if the current row element, that is n by 2, the ith column element in the current row does not sorry, not does not, we'll just call just have a count equals to this, plus in the same row, that is n by 2 row, we are going to pick the respective element in the column. So m minus I minus 1. Okay, So here, if count of C is 1, so we'll add it to single one pairs. Else if the C value is equals to 2, we'll add it to the double one pairs. Uh, okay, so this is of code for our rows part. Let's try to copy this and modify it for the same column parts. So if we have odd number of columns, we'll iterate through the row, and the ith element, for the ith row, sorry, uh, sorry, not the ith row, yeah, ith row, m minus m by 2 element. The column is fixed, so m by 2. Here also the column is fixed, and we are checking the ith row element in the m by 2 column with n minus I minus 1 row element in the same column. So yeah, we are checking, iterating over all rows, and we are checking respective element in the same column, that is m by 2, and we are adding it. One condition that we discussed is we have to check if we have both rows and columns as odd, then we'll have a single element, as you can see here, if both rows and columns are there. So will just add it here, or we can add it in the second case also. So if the number of columns are also odd, and we have the center element as 1, we'll make it to 0. So that means to our answer, we'll add one more extra value, 1. So row and column are odd, and our center element is 1. So we'll make it to 0. Okay. Yeah, we have the count of zeros and ones now. Now let's go through what we discussed in the logic and write the same here. We are not counting zero pairs, done. So if two ones, that is double one pairs, are even, double one pairs are even, then we can simply return the answer that we already have plus number of single one pairs which are converted to zero zeros. Else it is odd, then we have to check if single ones are equals to 0. If single ones are equals to 0 and we are having odd number of double ones, so we can add the value of 2 to answer, that is we are converting two ones to zeros, so two flips. Else we are going to return, as we discussed, one flip to make one of the 10 to 11 plus remaining pairs of single ones, right? So if we just cancel this out, we'll just keep it like this for better understanding. So yeah, first we'll make one of these 10 pairs to 11, or yeah, we'll make them to 11, and we'll just as you can see, add the remaining of s1 single ones pairs. Okay, so this is what we are doing. So let's just run this code. Yeah, so yeah, we are getting a wrong answer. Let's just check. Yeah, here as we can see, uh, we are iterating through the entire matrix. We only want to iterate till half of the minute, n by 2 and m by 2. Yeah, so let's run it once again. Yeah, accepted. Sample test cases are accepted. Let's just submit it and check. Okay, yeah, our code is accepted. So yeah, this was the third question. that is it for today's video. And if you are interested in programming and want to become a better problem solver, you can check out our 3-month long Smart Coder course, which helps you in mastering data structures and algorithms. Link is in the description. You can click on it to know more about the course. And if you like this video, please share it with your friends and subscribe to our channel for more such content. Until the next video, this is Jayan Sidam signing off.